Around 4.53 billion years ago, a Mars-sized body collided with Earth, and the resulting debris from both Earth and the impactor accumulated to form our natural satellite, the Moon. Have you ever thought about why the Earth rotates around the Sun? Or why the Moon rotates around the Earth? Many would probably say the gravitational force behind it. But is it only due to gravitational force? Or is there any other reason? In this video, we will learn about it. All the planets and the Sun, along with asteroids and comets, and multiple other objects, revolve around an effective center of mass known as the barycenter of the solar system. Because the mass of the Sun is so much larger than everything else, that barycenter is close to the Sun. On the other hand, in our solar system, the object that was formed earlier is the Sun. Now, according to the cosmological Big Bang theory, our Sun is formed first. And after a very long time, a few billion years, the matter that remains vast from the Sun is gravitationally collected due to a gradual decrease in the system's temperature. In this way, our Earth is formed, having an age of 4.543 billion years, while on the other hand, our Moon is the subplant of the Earth, having an age much smaller than the Earth. Remember that the Moon forms in the same way that the Earth does around the Sun. First, we discussed what makes the Earth spin on its axis every day. To answer this tricky question, we have to look back in time to when the Earth was born, 4.543 billion years ago. We have to ask, why did the Earth start spinning in the first place? When our solar system formed out of a gas cloud called a nebula, lots of dust and gas came together due to the force of gravity. The dust and gas were already moving around in a circle. As it all clumped together to form the Sun and planets, these new objects started to spin, and then spin faster. But why does the Earth rotate around the Sun? Let's think about this. We can think of a diagram to understand the rotation of the Earth around the Sun. Suppose there is the Sun, and here is the Earth. The Earth now has a velocity toward the Sun as a result of the gravitational force between the Sun and the Earth. Again, the Earth has its velocity, which acts perpendicular to the Earth. We know velocity is a vector quantity, and when two vector quantities act in different directions, their resultant velocity is found along the middle of the two vector quantities. Since the two velocities also act in different directions in the Earth's orbit, the Earth moves along the resultant velocity of the two velocities along the middle of the two velocities, and this happens again and again until the Earth returns to its previous state. And this is how the Earth revolves around the Sun in an elliptical path. And since there is no air barrier in space, this rotation never stops. The same thing happens on the Moon. It is said that 4.53 billion years ago, a Mars-sized body hit the Earth, and then a part of the Earth separated from the rest, which we know as the Moon. We know that the speed at which an object is thrown from the Earth and does not return to it is called escape velocity, and this velocity is at least 7,300 meters per second. When the Moon separated from the Earth, it continued to revolve around the Earth at the same velocity with which it had separated.